Video compression. Basically, video compression is reducing video size without losing quality. Now, let us understand what is a video. Video is a visual multimedia source that combines a sequence of images to form a moving image. Video compression is a very important aspect of how video streaming websites like YouTube, Netflix and Hulu work. Without it, you won't be able to stream such a high quality, high frame videos like this one. Let's assume you are watching a video with a resolution of 1920 by 1080 pixels. That's like 2 million pixels per frame. And in this case, you have got 30 frames per second. That's a whopping 62 million pixels per second. If each pixel needs 3 bytes of information, you are looking at 178 MBs of data per second, which is completely uncompressed. That would be 51 GBs of information for a single 5-minute video. We have got pretty fast internet here, but we can only download 2.5 GB in 5 minutes. That's a long way away from 51 GB. Fortunately, a fine YouTube video is not 51 GB. It is in fact more like 72 MBs. That's like 700 times smaller. How did they do that? So that's the magic of video compression, which works mostly by minimizing the redundancy in the video data. So here's what you guys need to know. There are two ways of compression: spatial compression and temporal compression, also known as intra-frame and interframe respectively. I'll be describing each of these in terms of the JPEG image format and the MPEG video format. Interframe compression is applied only to individual video frames. To compress a video frame, you can use the same process that's used to compress a still image like a JPEG. When a JPEG is created, color information of image is reduced in process called chroma subsampling. And then the image is split into sections of 8 by 8 pixels called macro blocks. Then all of this fancy stuff is done to these blocks to further reduce the file size. It's easy to see this effect on the image that has been saved with a high amount of compression. All those ugly looking squares are known as compression artifacts. Some images like this red square can be compressed more easily than others like this complicated photograph because red square is very simple with a lot more redundancy, but that's how a JPEG uses spatial compression. Now for a MPEG, sometimes called motion JPEG, things are a bit more complicated than just lining up a whole bunch of JPEGs one after the other to be used as a video frames. Doing it that way would not allow for interframe or temporal compression. Temporal compression works again by reducing the redundancy. If you go through a video, you will notice that many frames are completely identical. That's redundancy, which can be easily compressed. Like JPEG, the MPEG standard break video frame into 8 by 8 pixels macro block, and each macro block receives instructions on what to do with the pixels they already have. There are instructions for staying exactly the same for moving, rotating, changing color, changing completely and so on. Video frames with instructions like these are called as keyframes, and they use about half as much as data as an iframe, which is pretty much just a JPEG. There are also B frames, which are predictions or interpolations between I and P frames. B frames use a quarter as much as data as I frame, so they really save a lot of space. This is all pretty easy to see on a video file that has been saved in an extremely low quality setting. Like what you are seeing right now. Again, all these awful square thingies are called as compression artifacts. Furthermore, sometimes a video file will be corrupted or missing some data. When that happens, you get an effect like this one. This particular effect is caused by missing iframe, which would have cleared away the old image to make a room for a new one. Without the iframe, the list of changes in the following B and P frames are applied to the wrong image. So now, you know why a video sometimes looks weird. It gets all blocky. Those artifacts are a result of video compression being either too high or else some kind of error in the coding or transmission of the video data. If none of that made any sense, everything I have said can be broken down to one thing, that is bitrate. The bitrate is the amount of data or bits that are being used every second. If a video has a low bitrate, it will be low resolution or low quality with lots of common compression artifacts. If a video has a high bitrate, it will be high quality and high resolution so that more bits you have to work with, the better video will look. Video compression is balancing act between a good looking video or a small file size. You cannot expect both. You must compromise for the same. This is all about video compression. Thank you.